Section 3.3 talks about differentiation rules, and here we're going to be using shortcuts. Instead of using the definition, we're going to be using shortcuts to find derivatives of functions that we never discussed before. For example, if I was to say y equal x to the 100, then if you say f prime of x is the limit as h approaches 0, f of 100 plus h minus f of x over h, well, x plus h to the 100 will be an issue. So even though we took a derivative of a lot of functions, we handpicked those functions to work. This is 101 term. We need to use like Pascal's triangle or binomial theorem to expand that. That's a problem. So we have shortcuts for those. The most used rule is the power rule. And the power rule says if you have a variable raised to a number, now any real number, that would mean what? Well, positive powers, negative powers, whatever it is. If you want to take a derivative of that, you simply bring that power down and subtract 1 from the power. So if I want to take a derivative of x to the 100, all what I have to do is say the derivative is bring the power down and subtract 1 from the power. And that's pretty much it. And if you do all of this work, you will get that answer. And we'll practice that. You need to remember that the derivative of a constant is 0. Remember, a constant y equals c is a horizontal line. And the slope of the tangent of the horizontal line is always 0. And the derivative of x is 1. So recall again, if you have a straight line, the slope of the tangent is the slope of the line. And if I'm given y equal x, well, the slope of that line is 1, therefore the derivative is 1. Now these things will become second nature since we're going to use them so much. Few rules that allow us to take derivative of things that are added or subtracted. If you see a function multiplied by a constant, you could ignore the constant completely. Find the derivative of the function and multiply the results. And those two are pretty much straightforward. It says if you've taken a derivative of two functions added, take the derivative of the first, the derivative of the second, and add the results. And if they're subtracted, you could do the same. So when I look at something like 106, I'm going to apply these rules. Take a derivative. Well, I see two things added. When I say what's f prime, well, that's going to be derivative of the first plus derivative of the second. Well, this is a power function. I'm going to bring the power down, subtract 1 from the power. And a derivative of a constant is 0. Of course, you don't have to write that, but for now, let's practice writing everything out. And that's my answer, and done deal. And if I look at 108, I want to take a derivative of two things subtracted. So added or subtracted only. I could say the derivative, take a derivative of this, take a derivative of this, and subtract the result. What's the derivative of this? Well, the 4 you ignore, because that's a constant, according to that rule right there. X squared, bring the power down, subtract 1 from the power. There you go. And here, since this is a straight line, well, you could say ignore the 7 because that's a constant. What's the derivative of x? A 1. Or if you're looking at 7x, y equal mx. If it's a straight line, the slope of the line and the slope of the tangent are the same. So the slope of the line is 7 and the slope of the tangent is 7. Either way, you get the same answer. It doesn't matter how you think of it. Now you multiply those, and that will be my answer. And here, well, we see this is in the denominator. They never gave us anything for division. Well, we know how to rewrite this as well. A power function, we could move this up. Remember that we could do that. And remember, if we come across a radical, we could write that as a power function. which is why this is extremely important. It helps with most functions that we come across. If I take a derivative now, bring the power down, subtract 1 from the power. The 2 I'll ignore, it's a constant. Derivative of x to the negative 1, bring the power down, subtract 1 from the power. So my answer would be 4x cubed minus 2 over x squared. And if I look at the next number, what I have to do here is simplify this just a bit to make it look like a power function. And here it is. And when you take a derivative, I ignore the 1/3, that's a constant. Bring the power down, subtract 1 from the power. Bring the power down, subtract 1 from the power. And derivative of a constant is 0. So the derivative will be x squared plus 4 thirds x, or 4x over 3, that's saying the same thing. And this is pretty much how we're going to play this game now. Things are going to get a bit nicer than shorter in so many ways and easier. Well, we go back to the same question that we never get sick of asking. Find an equation of a tangent line at the given point. Y minus y1 equal m into x minus x1. There it is, done deal. What's missing? The slope. How do you find the slope? You take a derivative. What's the derivative? So if I ignore the 3, bring the power down, you end up multiplying those every time. That's 6x. Derivative of mx is the slope of the line. Well, that's just 4, and that's a 0. If I evaluate this at x equals 0, what do I get? I'll get 6 times 0 plus 4. So y prime is 4. There it is, done. How about this problem? Well, if x equals 8, y would be 8 squared, that's 64, plus 4 over 8 is a half minus 10. That will be 54 plus 1 half. So 54 and a half. That's 109 over 2. I got the point. I need the slope. F prime is, and this is really 4x to the negative 1. So that is 2x. Bring the power down, subtract 1 from the power, and that's a 0. So f prime is 2x minus 4 over x squared. Evaluated at x equals 8. That would be 16 minus 4 over 64. And that would be, let me see how I'm going to squish this in. Okay, I know how to fix that really quick. There. Get a bit more space out of that one. Oh boy. And what this becomes is 16 minus divided by 4. 4 divided, so that is 16 times 16. 256 minus 1. 255 over 16. So the equation of the line would be y minus y1 equals m into x minus x1. And there it is. All right. How about this problem? Find the point on the graph of y equal f of x equal x cubed such that, so they want to find a point, okay, such that the tangent line at that point has an x-intercept of 6. Well, let's put things together. X-intercept of 6. So if x equal 6, I want y to equal 0. That's a point. Tangent line, I need a tangent slope. Well, how do you do that? You take f prime which equals, bring the power down, subtract 1 from the power. Okay, now we have all the information. Let's see what is it they want. Find the point on the graph of this such that the tangent line has an x-intercept of 0, 6. Okay, well, if I want x to equal 6 at that one point, that would be 3 times 6 squared. That is 3 times 36. And what is that? 108. So find the point on the graph of y equal x cubed. The point will be 108 and 108 cubed. That's the point on the graph where the tangent line will has an x-intercept of 6, 0. All right. How about this problem? Determine all the points on the graph where this function has a tangent line that's horizontal, a tangent line with a slope of -1. Okay, well, let's see. If I want to find the slope of the line, slope of the tangent is the derivative. Bring the power down, subtract 1 from the power. Bring the power down, subtract 1 from the power. And a -1. So if I want a horizontal line, that means the slope of that line is 0. Well, there's the slope of the line. Where does 3x squared plus 2x minus 1 equal 0? That's when x equal 1/3 or -1. So determine all the points on the graph of this function where the horizontal line is tangent. That's for x equal 1/3 and y and x equal 1/3 and -1. And if I want the points, probably they're going to ask for these points. You plug them in to figure out the x and the y, which is fairly simple. Plug -1 in. At -1, we're looking at -1 plus 1 plus 1 minus 1. That's a 0. And if you put 1/3, can you guess what you're going to get? Well, let's see. 1/27 plus 1/9 minus 1/3 minus 1. So all over 27. That's 1. That's 3. That's 9. And that's 27. And whatever that is -36 plus 4. That's -32 over 27. On a test or quiz, well, we don't have quizzes, on exams, this is all I want. No need to waste time finding for the homework you should do it, but how about this problem? I want the tangent line to have a slope of -1. There's the slope. I want the slope of the tangent to be -1. I want 3x squared plus 2x minus 1 to equal -1. That means I want 3x squared plus 2x to equal 0. Or x into 3x plus 2 to equal 0. That happens when x equals 0 or -2/3. Again, if you just yield the x coordinates of the point, that's sufficient. That's good enough. Next problem. Suppose I'm looking at the following figure. Now let me just change the view so you can see the whole thing really quick. Okay. Okay, and I had to make a few adjustments. For the following exercises, use the following figure. Again, we used this before. F of x, well, let's see, any point that's going to lie on F on this region, that's going to have a slope of, let's see, what's the slope? Let's find 2 points. Closest 2 points. Let's say those 2 points. You rise 1 down, 1 to the right. So -1. Again, any 2 points will do. It doesn't matter. And if I fall on this part of the line, then the slope is, again, any 2 points. Rise 1, run 1. That's 1. If I happen to fall on g of x anywhere on this line, the slope will be, let's see, again, rise over 1. Wow, that's 1 as well. And if I happen to fall on that piece, the slope will be, it's a horizontal line, and the slope of any horizontal line is 0. Well, let's see how this plays. I'm going to take a derivative of x. That's going to be, well, the derivative of the first plus derivative of the second. So when they say what's h prime of 1, that's f prime of 1 plus g prime of 1. And that doesn't look very pretty. That's how it looks like. Okay, and what would that be? Well, let's see. At 1, I'm right here. So I'm using, if I go to f, I am at -1. And g is a 1, so that happened to be a 0. And if I go to h prime of 3, that is f prime of 3 plus g prime of 3. Again, it's based on this now. And this is f prime of 4 plus g prime of 4. And that's basically it. So that would be what? At 3, I'm right here. Well, if I go to f, that does not exist because that's a corner, if you remember. And that will be a 0, but if one of those do not exist, automatically the answer does not exist. It's undefined. And if I look at 4, 4 is right there. F would be the yellow. That will be a positive 1. That's 1 over 1. And G at that point will be a 0, so that's a 1. Now we have 2 more rules to worry about. One of them is called the product rule. This one seems to be easier for students to remember. And the quotient rule is a bit more complicated. Well, the product rule says if you have 2 functions multiplied and you want to take a derivative of those, that wouldn't be derivative of the first times derivative of the second. It turns out you have to take a derivative of the first times the second plus the first times derivative of the second. Since it's an addition, it doesn't matter which order you take the derivative of. So the way you remember it, take derivative of one of those multiplied by the second, and take a derivative of the other times the first in any order. It makes no difference. So these are 2 functions multiplied. If I want to find the derivative of f, I'll take derivative of the first. Well, derivative of x is 1, derivative of 2 is 0, times the second, plus the first. Derivative of the second will be 4x. Now, that's the actual calculus. Now comes the algebra. You need to clean that up. That is 2x squared minus 3 plus 4x squared plus 8x. So if on your test I say do not simplify, I want the first boxed answer. But for the homework, you need to clean it up to match it with the back of the book. So if I combine those, I notice that's 2x squared plus 4x squared, that's 6x squared plus 8x minus 3. And the same deal here. If I take a derivative of the first is 2t plus 2 times the second plus the first times derivative of the second. Derivative of the second is 3t squared plus 5. Again, on a quiz, on a test, this is what I want. And to match it with the back of the book, you need to clean this up. So you need to multiply. That is 2t to the fourth plus 10t squared plus 2t cubed plus 10t. When you multiply those, oh boy, that's a big mess. That would be 3t to the fourth plus 5t squared plus 6t cubed plus 10t minus 9t squared minus 15. And 2, that's 5t to the fourth, t cubed and t cubed, that is 8t cubed, squares 10, 15, 15 minus 9 is 6, t, 20t, and a minus 15. Again, on your test, most likely I'm going to say do not simplify. That's all I want. Now, when we get to the division, again, that's the quotient rule, and that's a rule that students don't like that much. The algebra is heavy in it, and this is how it works. It says if you take a derivative of two things divided, before you forget, you're going to take the denominator and you're going to square it. Few students forget to write that. Get that out of the way. For the top, it's kind of like the product rule, but the order is extremely important because there's a minus. Notice the minus happens in front of the derivative of the denominator. So I take derivative of the top, that's 2x times the denominator. The minus must be in front of the derivative of the denominator. So it's kind of like the product rule. Derivative of top times bottom, derivative of bottom times top. But the derivative must be, the negative must be in front of the derivative of the denominator times the top. So again, like the product rule, you take derivative of the top times the bottom, derivative of the bottom times the top, but the minus must be in front of the derivative of the denominator. And again, on a test, if I say do not simplify, and most likely I will, that's all I want. And that's not because it's not important to clean them up. You will clean this up. I just want to make sure you know how to do the calculus. That's 2x cubed minus, for the homework you need to match it up, negative 2x times x squared, negative 2x cubed, negative 2x times 4, negative 8x, divided by the denominator squared. And that will be negative 16x divided by x squared minus 4 squared. And there it is. Oh, a bit more space than we want. It's okay. How about the following problem? It says, in the following exercise, find the equation of a tangent line. Y minus y1 equal m into x minus x. There you go. Done. What do I need? Slope of the tangent. It's the quotient rule. Well, what does that mean? That means before I forget, I'm going to write the denominator squared. And the way it works, the minus is going to be in front of the derivative of the denominator. So I have a choice. Take a derivative of the top times the bottom. That's 2 times x minus 1. Take derivative of the denominator, which is 1 times the top. The minus must be in front of the derivative of the denominator. Now, if I clean this up, that is 2x minus 2 minus 2x over x minus 1 squared. Those cancel out, and I'm left with y prime equaling negative 2 over x minus 1 squared. If I evaluate that at x equal negative 1, I'm looking at y prime equal negative 2 over negative 1 minus 1 squared. That is negative 2 over 4. Y prime is negative 1/2. So as you see, the quotient rule is pretty lengthy. That's normal. That's how it works normally. All right, and now I just want to practice. Assume that f and g are both differentiables. That means the derivative exists for all x. Find the derivative of h. Well, let's see. This is a constant I ignore. Derivative of f will be simply f prime of x. This is a constant I ignore. The derivative of g will be g prime of x. So that's a fine answer. And if you like to write it as 4f prime of x plus g prime of x over 7, that's the same thing. It doesn't matter. And if I get to this problem, actually, let's just leave it like that. That's okay. If I want to find h prime of x, well, notice that's a constant I could ignore. And here I have to apply the product rule, derivative of the first times the second, plus the first times derivative of the second. And that's basically it. And if you want to write that over 2, that's also fine. That's really what it is. And that's pretty much it for this section. Now, I added few problems on my own because there aren't enough problems for you to practice on the quotient rule. So I added 2 problems and I gave you the answers. Now, the product rule and the product rule and the quotient rule, those come up a lot more than you like. So you really need to get them out. So I want to find the derivative of that, and the answer is right next to it. And I want to find the derivative of this, and the answer is right next to it. And that's pretty much it for this section.